So in this set of problems, we are going to look at the work we did earlier this week. So if you were watching the video, I'm assuming that you were trying to check your answers or you were absent and are looking for additional information. So on Monday and Wednesday of this week, we talked a little bit about the difference between doing a perfect square where we have an x term and a square root term. So in doing the first problem, we're going to complete the problem. So it's a generic rectangle problem. So we end up with this x squared, negative 7 times the x is negative 7x. X times negative 7 is also negative 7x. And negative 7 times negative 7 is 49. This is our common terms here, negative 7x, negative 7x. So the final answer here would be x squared minus 14x plus 49. One of the comments I made to classes about the second problem is that the only difference between the first answer and the second answer is the variable part of it. So the first problem, the term is an x term, and the second problem is a square root term. So if we do a generic rectangle for the second problem, we should end up with something squared minus 14 times something plus 49. There should be a negative 14 in that generic rectangle and a positive 49 in that rectangle. What will be different will be the x part of it will no longer be an x, but it will be the square root. So for the problem, square root of x minus 3 minus 7 point squared, so for our generic rectangle, it'll be the square root of x minus 3 minus 7 times the square root of x minus 3 minus 7, so we get the 2 by 2. So in the lower left-hand corner, instead of being x times x squared, we have the square root of x minus 3 times the square root of x minus 3, so we end up with this square root of x minus 3 squared. So again, something squared, the first problem is x, and the second problem is the square root of x minus 3. We have negative 7 times the square root, and then the square root times negative 7. And then the top right-hand corner, negative 7 times negative 7 is 49. So I said, again, we should end up with a 49 in our final answer. We do. We should have a negative 14 times something. And that negative 14 times something is right here, just like we had negative 7 and negative 7 for negative 14x. Here we have negative 7 times the square root, and then another negative 7 times a square root, and the square roots are the same thing. So we have 14 of them, 14 square roots. And so the answer is we have something squared, x minus 3 squared. We have 14 x minus the square root of x minus 3's, and we have a 49. So the numbers do not change from the generic rectangle. They both have a negative 14, they both have a 49. The only difference in terms of the x term is that it's a square root now instead of an x. Now the difference here is in the first problem we were done. In the second problem, because a square root and a squaring are inverse of each other, when I multiply a square root and an exponent of 2, I get actually an exponent of 1 because the square root has an exponent of half, and 1/2 times 2 is 1. So in the first term, I can actually square the square root, and I end up with x minus 3 minus 14 times the square root of x minus 3 plus 49. So keep in mind that, like when we did imaginary numbers, we have like 16i squared. We replace the I squared with negative 1, because that's our rule. Here, as we're squaring a square root, that makes the exponent 1, so we replace that with just simply what's underneath the square root. We do have a pair of like terms. That's the negative 3 and the 49. So the final answer is x minus 14 times the square root of x minus 3 plus 46. It's 49 minus 3 is 46. In problem number 3, If you would square the right side, the way it's written, we would end up having an answer very similar to the problem on the right on this previous screen. And what we would end up with is we'd have a square root in our answer when we did the generic rectangle. So just simply squaring the left side as well as the right side doesn't help us, because squaring the left side is going to give me a square root in the middle term. So when we have problems involving square roots, what we want to do is make sure that in the end we have the square root by itself. So the square root of x minus 7 minus 12 equals 8. So the first step is we're going to add 12 to both sides to get the square root by itself. So I end up with the square root is equal to 20. I apologize for this smart board. It seems to be having some issues. We square both sides, and in squaring both sides, the squaring gets rid of the square root, so the left side becomes x minus 7, and the right side, we're squaring the 20, and that makes it 400. And then we add 7 to find out x is 407. So make sure that you get the square root isolated by itself, so that when you square it, basically the square root goes away, because it's an exponent of a half times the 2 makes a 1. So problem 4, we have 2 times the square root of x plus 4 plus 15 equals 10. So here, we want to get the square root by itself. So the first step is we're going to subtract 15 from both sides. Then we're going to divide both sides by 2. So we end up with the square root of x plus 4 equals negative 2.5. Now at this point, and maybe even the step before that, at this point we're done. We can't go any further, because in this problem you cannot take the square root of a number or a value of some sort and get a negative answer. So this one here we talked about in video as well as earlier. This has no solution, because you cannot get the square root of a number and get a negative answer. Anytime the number underneath the square root is negative, our final answer would have I in it. This doesn't have I in it, so that tells me that there's no solution here. And then the last problem, square root of x minus 6 divided by 2 plus 15 is 28. So the first step here is we're going to subtract away 15. So we end up with this x minus 6 all over 2 equals 13. And then we're going to undo the multiplication problem by doubling both sides. That gives me the square root of x minus 6 equals 26. Now I got the square root by itself. So when I square both sides, the left side ends up being just x minus 6. And then the right side, 26 squared, is 676. Add 6 to both sides, and we end up with 682. So hopefully the problems here clarified your own thinking. You're able, if you made mistakes, hopefully you're able to see why or what you should have done in terms of the problem and why. But again, the key here, especially in 3, 4, and 5, when you get the square root by itself, so that when you square both sides, that square root goes away. We will continue with our work on square roots in our next class period. So hopefully, if you've made some mistakes in the next class, hopefully those mistakes will be minimal.